Most engineers obsess over picking the right model, crafting the perfect prompt, or chasing the latest benchmark. But there's a quieter problem destroying productivity in AI-assisted development. Every single session starts from absolute zero. The model has no memory of your architecture decisions, your team debates, or why that one module is wired the way it is. Until you solve the forgetting problem, everything else is just noise. Imagine hiring a brilliant contractor who shows up to your office every morning with complete amnesia. They're talented, fast, and confident, but they have no idea what was decided in yesterday's meeting, what failed last quarter, or which parts of the system are delicate. That's not a hypothetical. That's your AI assistant right now. The cold start problem means you're either rebuilding context manually every session, or you're flying blind and hoping for the best. An architecture decision record that only documents the final choice is actually dangerous in an AI-assisted workflow. When the model sees an outcome with no reasoning, it will confidently suggest reversing that decision, because from its perspective, the alternative looks perfectly reasonable. The real value of an ADR is documenting the roads not taken, the options that were considered and rejected, and the specific constraints that ruled them out. That's the information that keeps AI suggestions inside your actual boundaries, rather than wandering into territory you've already ruled out. Not all code is created equal, and your information architecture should reflect that. A simple CRUD endpoint and your authentication system or billing flow carry completely different levels of risk, complexity, and institutional knowledge. When you treat them the same, giving the model no indication that one is sensitive, you get suggestions that sound confident and are technically coherent, but would catastrophically break production. Module-level context files that explain the stakes, the constraints, and the landmines are what separate a codebase the AI can safely navigate from one it will quietly destroy. There's a fundamental asymmetry between rules you write in a file and rules you repeat in a prompt. A hook that blocks writes to sensitive paths fires every single time, automatically, without you remembering to mention it. A prompt instruction depends entirely on you remembering to include it and on the model choosing to respect it in that session. The most resilient AI workflows externalize their constraints into the system itself. Linters, pre-commit hooks, automated checks, so that the guardrails are structural rather than conversational. Memory that lives in files is reliable. Memory that lives in your head is a liability. Here's an uncomfortable audit question. If you handed your codebase to something that can't read Slack history, can't ask clarifying questions, and starts every session having forgotten everything, how far would it get before causing damage? Most codebases were designed to be legible to humans who can ask questions, attend stand-ups, and absorb tribal knowledge over months. That design philosophy completely breaks down with AI-assisted development. A single README, no decision records, no module context. That's not an AI-ready codebase. That's a first-day intern experience, repeated forever. The most important mindset shift in AI-assisted engineering is accepting that the model's capability is largely fixed in any given session. What varies is the quality of context you've given it to work with. When AI suggestions feel frustrating or off-base, the instinct is to tweak the prompt or try a different model. But the first audit question should be, does this codebase carry its own memory, or does it depend on a human to reconstruct context every time? The teams getting the most out of AI aren't necessarily using better models. They've designed systems that are legible to something that starts every conversation from zero. The engineers who crack this discipline discover something remarkable. When you give the model rich, structured, embedded context, real decision records, module-level documentation, automated guardrails, it stops feeling like a first-day intern and starts feeling like a senior collaborator who actually understands the codebase. This is the underappreciated frontier of AI engineering right now. Not better prompting techniques, not the next model release. Designing codebases that carry their own memory, so the model's intelligence finally has something worthy to work with. Build that system, and the model will genuinely surprise you.